All right, hopefully I'm recording. New account for whatever reason. All right, this is the first video of, I hope, many. I'm hoping about 55 or 60, taking us from Algebra 1 through some calculus. And mostly fundamentals. What you need to be able to move up the ladder in this discipline. All right, so hoping to do maybe 4 problems at a time. I think I'll structure it sequentially: linear, quadratic, cubic, roots, absolute value. But many of the principles of conversion for one function relate to the next. And of course, the course is going to be based on the numbers 0 and 1. Let's see, I did put a few notes on the side here. So this particular video, we'll start with writing the equation of a line given 2 points, and the rule that we will follow is whatever the easiest way of doing something, whatever that easiest way is, at least what I think at the moment is the easiest, we will approach it in that manner. All right, so writing equation of a line given 2 points, converting to slope intercept form, naming 4 points on a line quickly and easily, and solving linear functions, some basic ones. Graphical approximations first to get some conceptual awareness, and then using inverse operations. So right off the bat, we can forget about my dear Aunt Sally. That's not what this course is about. And I'll explain things slowly over time. So we will do rapid fire 5 with each situation. So we'll start with that equation of a line. I'll talk a little bit more right now about how this whole series is going to progress. I'm doing it this way so that people can access different questions more easily, group them. You know, I don't teach that way. I generally do linear, exponential, logs, all at the same time, so that we don't develop a linear mindset. But I don't think it's really creating a library here that people can access quickly. So there will be different times when I do a worksheet that incorporates all of the things that we're going to cover. I got to do that periodically because I do believe in distributive learning. I do not believe sequential instruction is getting the job done. I think you can get through Algebra 1, Algebra 2. I've had students who've gone from Algebra 1 to some fundamental calculus principles in 3-4 weeks. Of course, it's 4 or 5 hours a day. It's intensive, but we cover the whole range of sinusoids and logarithms. It can be done, but it's a little harder to do on a computer here. We'll give it a try. All right, so let's start with rapid fire 4. So we're going to do 4 linear equations, writing the equation, the mechanics, and over the course of the these tutorials, we'll build concept as we move forward. All right, so what's the best way to write the equation of a line? Not the ones that are in the textbooks, but we, basically going to have a point slope form, but more of a left-right orientation. All right, so generally speaking, you'll be given questions with 2 points written in this kind of format. I suggest for beginners to transfer these to X1 into tabular form. So we'll just start with a 5. Right? So what's the first thing we're going to do? We're going to write y equals, we're going to make a parentheses, we're going to put the letter X right there. And if that's a 5, we're going to say -5. All right, we've already created a 0. And so if we want the number 17, we can get that y value pretty easily just by writing it, power of the marker. Okay, I guess I got to move this back a little bit. Okay, and then we just got 2 steps of conversion. So we've already done that. The next thing we have to do is put our second X in, 7. We can see a change of 2. That change of 2 goes in the denominator. And we need a 17 to 28. How do you get from 17 to 28? You got to go up 11 units. So you have to go up 11 on this side, you have to go up 2 on this side, and that's really our conversion process, just mechanics. That's all I'm doing is mechanics. Although there was a subtle difference there in how I approached it. I basically said, how do you get from 17 to 21, 28, up 11? How do you get from here to here? That's different than doing y2 minus y1. It's just a subtle difference. It's easier. So we're going to do it that way. All right, now we're going to practice that first step. And that's all we're going to do. I'm going to give you a new number. Instead of 5, I'm going to write minus 6. So what do you write over here? X plus 6. Okay, I'm going to give you a different number. I'm going to go 8. All right, so what do you write over here? Positive 8, minus 8. Why? Trying to create that 0. All right, one more. Let's go to minus 8. And you can learn to write plus 8. I think everybody can learn how to do that. All right, then the number over here is 9. You don't write 17, you write plus 9. The number over here is negative 7. Then over here you write minus 7. Okay. All right. And if this is minus 17, then you write minus 17. If it's a positive 17, you write positive 17. Okay. So we're going to get a couple of new values here. All right. Let's do 3, 9. What do you write over here? Y equals the X there. 3 minus 3. And I'm going to add it to the first power. Because later on, we're going to use the same technique to write square root functions, absolute value functions, quadratics. We're going to do the same exact thing that we're doing here. It's just we're going to add one more layer of computation. That's all it takes. All right, so I got a 9 here, so I write plus 9. All right, now we got to get the change. Okay, well, let's go to 7. What just happened? Your x's went from 3 to 7. They went up 4. Let's go from 9 to 0. How did you get from 9 to 0? You went down 9. That's a linear equation. Let's try one more. I'm not keeping count here, but I think one more will take care of this. Let's go minus 7 to 21. And let's go 10 to 100. Okay, you write the equation line, pause. I'm just going to do it from left to right. I'm going to actually do it the way I normally do it. Minus 7 to 10 is up 17. Once you change an X, 21 to 100 is what? 79? Up 79. Minus 7 means I'm writing X plus 7. And I want to get a 21. All right, so I had some notes here. I'm going to get rid of them. Principles of learning, distributive learning, order of operations, inverse order of operations, learning to think mathematically, all to be discussed in the future. All right, so we can write the equation of a line quickly. I'll write the equation of a line that you normally see in the textbooks. So I like to write y equals, oh, I don't know, 3/2 x minus 4 plus 5. There's a linear function. Textbooks would move that 5 to the other side, and that's called point slope. I don't think there's much difference between these two, but this is going to get us in the a x minus h squared plus k format, which you'll see for quadratics, which you'll also see for cubics in this form, plus m x minus h plus k. All right, so we are going to put it in that form because we're going to use it in other contexts. All right, so that's question 1. Writing the equation of a line given 2 points. What do you want to call this? I don't know. I think it's the Taylor form. How do you get from one place to the next? Taylor polynomials. All right, that's coming your way in a few years, provided you get a good enough foundation. All right, so here's a typical converting to slope intercept form. So let's go with y equals minus 5/2 x minus 7 plus 9. And we're trying to get to y equals mx plus b that everybody is so fond of that I don't think we'll use very much. Not right now anyway. Although it has some usages, that's for sure. Okay, so what do we have to do? We got to distribute the multiplication. All right, I guess I got to show this. Let's look at 8/2 times 4. All right? That's what I have. I got a parentheses and I got distribution here. I understand that, but I want to look at this multiplication. What's the way we can do it? And I think there's three ways to do it. One, you can say, do I need to see this differently? Okay, so first off, 8 divided by 2 is 4, and 4 times 4 is 16. So that's one way you can do it. You can do this division first and then multiply. I can't do that here. Unless we, work decimally, and we're trying to find easy ways to do things. You could have also said 8 times 4 is 32. 8 times 4 is 32 divided by 2. Boy, that's 16 as well. So I could have done the division first, then the multiplication. I could have also divided 2 into 4, and then I would have had 8 times 2 is 16. So I guess that's important. Yep. But bottom line is, you have to multiply and then divide, or divide and then multiply. Okay, but you certainly not, I don't, people butcher these things, so I'm not even quite sure what to say. All right, so let's do the distribution. Assume that you've had a pre-algebra and you got something out of it. Minus 5 times x, and then divided by 2. Minus times the minus is a positive, and 5 times 7 is 35, because I can't do any real simplification, so I'm just writing what I see. And then the question is, how do you add the number 9? Well, 9 is over 1, so hopefully you've had some elementary school math and you know that you got to have a common denominator. And I think you can see that 2 times 9 is 18 over 2. Okay, so I hope that with practice, we see that quickly and easily with a couple of days of practice. And so what's the final result? Minus 5x over 2, which could have also been written as minus 5 halves x mx, right? Plus b, I've got a couple of things over 2, 35 and 18, so 53. All right, so we'll do a bunch of these right now. And then we'll do some graphing later, because doing this is only helpful if you can also see all of the answers to this equation, which is what a graph is. All right, so let's look at y equals, let's do 3/4 parentheses x minus 9 plus 7. Okay, so you pause the video, you try, I'm just going to do it now. So I got 3x over 4 minus 27 over 4 plus, I need something over 4. 7 is what over 4? It's 28. So it looks like I've got 3x over 4 plus 1/4. One more, we'll just do one more, get us started. I'm not going to have problems with this if we do it every test for the entire semester. So let's look at y equals, how about we do 8/5 x plus 2 minus 9 again, we'll do that. All right, so what do you got? You got your 8 times x over 5. You got 8 times 2 is 16 over 5. You've got to get 9 over 5. That's going to be 45. And now we've got ourselves 8x over 5, take 16. So the way you want to handle 16 minus 45 is you want to do 45 minus 16, and you want to put a negative sign in front. Okay, so 45, 35, 29. So this is minus 29/5. I'm going fast here and talking at the same time. That means I could make a careless error without any difficulty. Hopefully I just didn't. All right, so that's going to be on every test the whole semester. And for those of you who are not actually taking this class in person, it's going to be a little different, because we're going to be doing worksheets, and I'm hoping that people can do those problems in 10 seconds or less 4 days from now. All right, so let's talk about naming 4 points on a line. So let's go with the textbook, y minus 6 equals, this is where 8/3 x minus 2, something like that. All right, so I'm hoping that people can look at this now from what we did a few moments ago and realize you're starting with the number 2 here. All right, because that's going to make a 0. Okay, and let's just concentrate on the x's. This tells me my x's are changing by 3. Well, that looks to be 5, 8, 11, so on. I could do that forever. All right, and I could go backwards, but it's easier to, it's easier to add 3 than subtract 3. think addition probably. Might have come before. I gotta be careful with those fingers. All right, so why are we picking these numbers? Well, if you put 2 in parentheses, you get a 0. If you put 5 in, 5 minus 2 is 3. If you put 8 in, 8 minus 2 is 6. If you put 11 in, 11 minus 2 is 9. Oh, geez. 0, 3, 6, 9. Oh, yes, division by 3. I could have done that first. Well, I think those are counting numbers. I don't think I need a calculator. All right, so I can see the first x, and I can see what makes multiples of 3. Numbers that are too bigger, but anyway, we won't get into that yet. All right, so if I make this 2, this becomes 0, which means this has to be 0. I personally don't be afraid to take subtraction of 6 and write it as addition of 6. Let's see if that's true. 7 minus 6 equals 1. 7 equals 1 plus 6. Oh, geez, subtraction on the left is the same as addition on the right. And I didn't even have to do this, did I? I didn't even have to do plus 6 plus 6. Oh, I hate that. All right. Ooh. God, I hope people can kind of add 6 to 1 in their head. And on the other side, the equal sign, just write the number 7. Anyway, so I've taken the minus 6, I put it on the other side. Now I hope we can really begin to see a 2 gets you a 6. All right. The only thing we haven't considered is the 8. Well, if 3 is the change in x, you know, you've had sums, this is algebra 2 right now, starting our algebra 2 class with a review of algebra 1. You should have studied x2 minus x1 as being the slope. The letter m, we're going to use the letter a, right, for a x minus h plus k. I keep wanting to say squared. Oh, the first power conversion. Yes, I'm gonna do that. It's unnecessary, but I'm gonna do it. All right, so where was I? A new problem. All right, so let's give you y equals minus 4/7, x plus 1. Oh, plus 5. All right, have at it. Pause the video, but I hope you look at it. -1. Oh, no, 6, 13, 20. 5. 1, -3, -7. Making sure that it works. Let's put 20 in for x. Let's put -7 in for y. Do we get truth? 20 plus 1, 21. 7 goes into 21, 3. -4 times 3, -12, plus 5. Seems to work. One last one. We're going to do this with exponentials, logarithms, cubics, sinusoids. Oh boy, we're going to have fun. What do I got here? I got y plus 2 equals -5. 30th. No, I don't want to reduce that one. Wouldn't I? 31. X minus, how about 100? Let's go for it. Okay, let's go. Wow, 100. Yeah, 31 goes into 0. Nice. Change by 31. We're going up. That's a positive rate. Yes. Well, 131, 162, 193. We're going to check that one out when we're done. Make sure we didn't make any careless errors. What makes a 0 on this side? Remember, could have moved it over here. Addition of 2, subtraction of 2. So that's what I want 100 to get me. All right, and now I'm doing what? Going down 5. -7, -12, -17. Boy, and I can plot those points. Got a nice little graph there going. All right, let's plug in 193. Let's do the math. 193 minus 100. Oh boy, 93. 31 goes into 93 3 times. 3 times minus 5, minus 15, minus 2, minus 17, move on. All right, so we named 4 points, converted to slope intercept. Solving a linear equation. All right, well, let's take it. So we have this linear equation, let's call it 3 halves x minus 4 plus 7. There's a linear equation, which is in the y column. And let's put a number in the y column. Let's put the number, I'm gonna get a canned one here. So let's get something nice here. Let's go to 21. When does this thing equal 21? Let's graphically approximate first. Okay, so our first attempt at graphing. Okay, I know that I can kind of see from our earlier work that 4 gets me to 7. So let's call that 1. Right, and 4 is about here, 7 is about here. Rough estimate. 4, 7. Okay, and it looks like I'm going to change by 2, which I could show, you know, twice that distance, and up 3. I could show that. That looks about a 3 to 2 ratio. Or I could, I suppose, you know, write down what I know. I know a 4 gets me a 7, and if I change by 2, then a 6 gets me 10. And I got to keep going up by 3 and 2. This changes by 2. So this is 610. 610, I'll write that. So that's a height of 10. And I'm trying to get to a height of 21. 21 appears to me to be about there. All right, so I'm looking for an x value here. And this is 6. I'm gonna go like up 8. I'm gonna take a big guess at 14, just from an eyeball view. All right, I don't know how well I did there, but let's find out. Let's find out. Let's use a little math. Let's not do the minus 7 on both sides. Let's just do it the way that I allow my students to do it at the board. So we got ourselves 21 here. So I'll take 7 away from 21, just 14. Division by 2 is multiplication by 2 on the other side, 28. Looks like I'm dividing by 3. I thought I had an integer range here. And then I'm adding 4. I'm adding 4, I got 28 over 3 plus 12 over 3, which is 40 over 3. Wow. 13 1/3. And I guess 14. Where did I go wrong here thinking that I needed a, oh, I had an odd. Did I make a mistake here? Oh, I didn't. Just dividing by the odd. I didn't think about that. Yeah, I really needed a multiple of 3 there. Yeah. Oh, well. Yeah, but the guess wasn't too bad. I guess 14. It looks like it was what, 13 2/3? Is that 13 1/3? Yeah. All right, so wasn't too bad. Let's try another one here. Let's try having you just solve and kind of guess. Let's do minus 3 halves. X minus 5 plus 9. Let's set that equal to. Can I do this one this time? Yeah, I think I can. Yeah, that shouldn't have been so hard. Shouldn't have been so hard. So let's do it real simple. Let's go 11, 6, 3 minus. Let's go 0. Okay, and I guess if we're finding a 0, we're finding the x-intercept. That's always good to hear. Plant the little seed. All right, so we're finding the x-intercept. All right, so what's 1 point you can put? We'll call that 5. We'll call that 9, and I know it's going down, so gonna get a little further over here. So 5, 9 right here. Again, over 2, down 3, boom. All right, so what's that look like? 5. That looks like 10. I'm looking at 13 again, something like that. Huh? Let's find out. Let's take a quick gander. All right, so I'm going to subtract 9. Oh, I'll do that this time. I'm going to multiply by 2. That's an 18. Boom. I'm going to divide by minus 3. Minus 3 goes into 18 6 times. And then I'm going to add 5. 11. I said 13. Yeah, the ballpark. That means I don't have to check my work. I got, you know, doing things from 2 different directions here and they're matching up. All right, one last one. And then we'll give you a quick quiz on all the things we just did. All right, So let's go with y equals, y minus 6 equals minus 11 over 5, x plus 2. All right. Oh, wait a minute, I'm doing an equation. Let's move the 6 to this side. And let's set this thing equal to what? Minus 10. Okay, we're gonna get a fractional answer here, I'm sure. I didn't spend much time with that. All right, so minus 2, 6. So we'll call that minus 2. Let's go up 6. That's about there. Over 5. Boom. Down 11. Boom. Maybe. All right, really ballpark figure here. And I'm trying to hit negative 10. Okay, I think negative 10 is going to be about here. And 2, 4, 6, what do you call it? 7-ish? Let's call it 7-ish. Real ballpark. All right, so what are we going to do next? Going to multiply, subtract 6. Minus 16. Let's actually move it. Multiply by 5. Multiply this by 5. Minus 80. Let's move it. Let's divide by minus 11. Which means we now have a positive answer. We were guessing 7 before. All right, it looks like my guess is a little too big. Subtracting 2, and if I subtract 2, I'm subtracting 22 over 11, which is 58 over 11. Oh, I was way off. Yeah, that maybe is a little bit bigger than 5. I guess 7. All right. I'll give you 4 questions. 1, write the equation line that passes through negative 3, 8. And how about we do 2, 20? Okay, number 2, convert to slope intercept. Y minus 3 equals minus 4/5 x plus x minus 7. Okay, that's number 2. Number 3, name 4 points. Why don't you name 4 points on that line so I don't have to write anything else first? All right, so we'll name 4 points on that line, and then we'll go to solving a linear equation. So let's go, let's give you a toughie. 2x minus 8 equals 5x plus 3. That's a little different than we just did. All right, you pause the video, you go ahead and try them. I'm just going to do them. I don't need to write a table. Well, yeah, I asked you to, so we'll do that. So minus 3, right? Minus 3 is x1, so I write x plus 3. I want 8. I get an 8 there. I'll put a 1 there because this is actually a conversion of something to the first power. It's going to change when we do quadratics, cubics, etc. All right, so let's just get that out of there for now. Where am I? Okay, minus 3 to 2. How do I get from minus 3 to 2? I go up 5. How do I get from 8 to 20? From 8 to 20, I go up 12. And that's your y values. Now you plug those x's in, and you can check it by plugging a 2 and putting in a 20 for y. Let's see if that actually satisfies things. Oh, such a nice 2 plus 3, 5. 5 goes into 5 nicely. 12 plus 8 is 20. You should get in the habit of doing that early on so that you actually get some correct answers quickly. Build your confidence a little bit. So that's 1. Boom, 1's done. I'm going to name 4 points on this line. All right, so what's the first thing I see? I see a 7. All right, and then that makes a 0 over here. What minus 3 equals 0? 3. And my x's are changing by 5. There's 12, there's 17, there's 22. All right, and my y values are going down by 4. Minus 1, minus 5, minus 9. Brain's getting a little tired actually already. So 22 minus 9, let's find out if that really does work. Let's put 22 in. Let's put minus 9 in here. All right, let's see if that works. Okay, so I guess space-wise, 22 minus 7, 15. Why is 15 nice? Because it's a multiple of 5. 3 times negative 4, negative 12, and we can see that that's negative 12. All right, now, what I didn't do is, I didn't give you a kind of a rise over run format. It's understood to be that. Okay, so it's really divided by 1. So these are in slope intercept form. So I'm going up at a 2-to-1 ratio starting at negative 8. So that's my minus 8, which means positive 3 is probably that height. I'm going over 1 up 2, boom. And on this one, I'm going over 1 and up 5. Over 1 and up 5. So I should have a fairly small, maybe around -4-ish intersection. And all I'm doing is finding the x value here of where these two lines intersect. Notice we're already starting to move into a little conceptual discussion at times. All right, so what am I gonna do? I like to keep my x's positive. So I'm gonna take 2x and bring it to the other side. Remember, 2x plus 3x is equal to 5x. And 3x is equal to 5x minus 2x. Now, we don't have to write a plus sign. We understand that's positive too. But addition of 2x is the same as subtraction on this side. So I can take 2x away from 5x and get 3x. I can take 3 away from 8, get -11. I guessed -4. -11 over 3 is x. Not a bad guess because -12 over 3 is. All right, so we got some mechanical practice in. All of that should have been learned in Algebra 1. I'm guessing there's probably a bunch of gaps in the class. And it's been a while probably because you probably did a geometry class. So we're starting off with a little review of some linear and as I say, I'm trying to build a little library here. So typically the first thing I cover in Algebra 2 class is logarithms, and that might be the case. But I'm going to build this kind of library system so that when we're doing our worksheets, if you need to find something, you'll be able to. All right, hope that makes some sense. And see you in class. And I guess I've learned how to let you make comments. So if you have any comments, feel free to send them my way.